didn't understand it, right? Like it didn't make sense to me. It seemed very fishy. Like,
So
do you
are we
remember that,
done with
Osco?
this? I have a question for you guys.
Oh, look who woke up. You're all partied out from all that Fourth of July celebrating. What's going on, SE?
Well, I don't want to interrupt. Are we done with this number thing or whatever we're doing?
Could you see the fireworks from Canada?
They saw it from space.
Hooah!
They said they could see the firework show in LA from space.
Dude, they were shooting fireworks in my neighborhood till like 4 in the morning, like nonstop.
No, LA looked wild. I saw someone posted a video of a plane flight over LA. It was crazy. And I saw
How we do
dudes
it over
doing
here.
absolutely ridiculously dangerous shit. They were playing baseball with Roman candles. They just had like huge bundles strapped together, like just wild, dangerous shit. It was so crazy.
You guys don't do that over there on the East Coast?
Play baseball with a Roman candle. I mean, we could have a Roman candle war or something. I never seen no one try to actually bat one. It's just coming crazy. I don't think I could even. The guy only hit one of them. He's probably drunk, but I don't think I could hit any of them. I don't even know how you time that up.
We just got bottle rockets legalized for the first time in like 2 decades here.
Yeah, they gave us little rinky-dink ones recently. You can have like
You guys are being good boys over there.
You have sparklers and some other goofy shit. Those little snakes, the things you throw at the ground and pop.
You guys got pop rocks, bro, and snappers, dude. That's what you get.
All right, Essie, what you got?
All right. Question. And this should start off another convo, but if I was to ask you guys, if I was to say a word, tell me what first thing comes in your mind.
Canadian.
Ready? The word is jerking.
Canadian.
Off.
Of course, right? Okay, let me post something. It's actually a cosmological scientific term right now. Jerking. And your favorite scientist, Jeremy?
Does any globe believer here believe that?
It's a
right
family
now?
channel.
How quick are you going to adopt this into your belief system, globe believers?
Well, that's the thing. Now you got to incorporate that word. It's part of cosmology now.
So now you're jerking?
It's a short video, but if you guys want, I could explain what it is.
So I know that jerk is like the third derivative. It's like the change in acceleration, I think. I'm not sure.
You got it, Omni? You
That's
got
knee
it?
jerk. That's knee jerk.
ZZ sent me a list of them because it's position, velocity, acceleration, jerk, snap, crackle, and
Spank.
pop.
Okay, pop, yeah.
The universe went Rice Krispies on us.
Well,
I guess so.
It could be a car. That if the car is changing acceleration, abruptly, that's jerk.
Like somebody that can't drive a clutch.
So a non-constant acceleration, a non-constant acceleration.
So it's velocity is change in position over time. Acceleration is change in velocity over time. Jerk is change in position over time. Snap is change in jerk over time. Crackle is change in
like
snap
making
over
this
time.
up, or are you actually reading this somewhere?
All I heard was JELLO.
This is what ZZ Pop sent me. He was telling me about this a couple weeks ago. And then pop is change in crackle over time.
He's literally trolling. He's got to be trolling you. There's no.
No,
there's no way.
actually, it's not. That's not trolling. Believe it or not.
He
You
forgot
guys
to
are getting
stop,
trolled
drop, and
then.
roll.
You guys are getting fucking trolled then.
Oh,
Yeah.
do
He
you
forgot
guys
to stop, drop, roll.
do you believe this? And can you explain it to us?
I can't. No, sorry, I'm not smart enough. When I read what ZZ Pop writes, it goes right over my my high school educated ass head.
Stop jerking
Typical
us around.
Glovers. Yeah.
All I know is the
Quit
universe
spanking.
is jerking and popping. Apparently,
Omni, do you believe this? You know, there's people who are gullible. You don't think, are you gullible for believing this or without evidence, or what are your
I
thoughts on
don't
this?
even know what the claim is. I know what jerk is. Jerk is the third derivative of motion. That's not. So if you don't believe that, you know, you're just in denial about reality. I have no idea what the universe is doing.
Jeremy said it was a type of rap dance.
I would question if the universe is doing a dance. So
We just added another word in our cosmological lexicon.
well, but it's
Jerking.
also for racing a car. I mean, that's not a cosmological term. I don't think.
Well, in this case, it is.
Yeah, okay, you can apply it to that.
and I don't know if they're just adding to it. It sounded from talking with ZZ Pop, it sounds like these terms have been around for a while.
No, they have been. They have been. It's the same as acceleration or velocity. It's just a less common version.
Can you explain it for us, Omni, if it's okay, or I could look it up?
Without the snap,
So
crack, pop, and roll.
so velocity is when you're moving, right? You're moving at a constant speed. Acceleration is you're speeding up or slowing down. Okay. Jerk is the amount that I'm speeding up or slowing down changes. Do you follow that?
Yes, thank you, Omni. So,
Okay.
are you familiar with like all this jerking?
With what?
Are you familiar with the jerking, the history of all this jerking?
I am familiar with beef jerky. I've heard of that.
How much jerk experience you got, bro?
Well, I have definitely observed some people to be a jerk, and some people have said I am a jerk. So does that count?
You got a degree in jerkery.
No, we're hopefully about the universe, but I guess we can look it up. But wait, so you believe? Do you believe this without the, I guess, evidence at your disposal,
So
or
I believe that jerk is the third derivative of motion. Okay, that you may not understand what I just said, but that has nothing to do with the universe or proof or anything. If you don't believe that, you are just in denial.
okay, but
Isn't a jerk like
What?
I have no idea how this applies to the universe. I haven't watched the video.
So we're in denial, or you're in denial, or you're in ignorance?
The denial is about whether or not. So, do you believe that acceleration is the second derivative of a path of motion, Richie?
I don't know why it'd be the second, the first, the third, the fourth. I don't know.
Yeah, you don't know. But if I told you, if you read in a book that acceleration is the second derivative of a path of motion, would you need evidence to believe that?
Man, I can go read Lord of the Rings or something, and like what, reading in a book as if that. Come on, bro.
Well, this is a case where do
Go
you
get your
believe
ring
that
and throw it in Mordor.
velocity is change in position over time? What you're doing is you're saying, do you believe in the definition of this word without evidence, which is kind of a dumb thing to ask.
That's because you believe in credentialism, and if it's coming from a
No,
credentialed,
it's because I believe in definitions.
Okay.
All right, what's the hang up? I'm back. Sorry, I had a phone call. Quit jerking around. Let's get back to it.
Like, do you need evidence that the color blue means that color? How would you know? You read it in a book, Richie. You read what the color blue was. There was a blue circle and it said blue next to it.
What's the
How
hang
would
up?
you
Is
know
it
if
about
that's
the
true?
definition of jerk?
The definition of jerk is the third derivative of acceleration. I called it before even seeing the video, or
And you said
seeing
it's the amount of how much you speed up or slow down.
it's the change in acceleration.
Yeah. Change in acceleration over time versus change in velocity over time
Okay.
versus change in
It's like
position over
it's
time.
like human
So it's
beings
how
have come up
fast
with
you
these
slow down and
categories.
how fast you speed up. So like saying the car goes 0 to 60 in 3 seconds would be like an example of jerk or something.
No, that'd be just acceleration. You could feather your brake pedal and change your deceleration as you decelerate.
Right.
That's what he's talking about.
Okay.
Yes.
How fast you slow down.
How
Or
fast you
accelerate.
decelerate. How much the
It-
deceleration changes over time.
Yes. Yeah.
You ever had somebody like trying to take a sip of water in the front seat of your car?
Yeah.
You're driving down the street and then they go to take
Then
a
you're a
sip and
jerk.
then you pound on the
That's
gas.
That's why they call it jerk.
I do
This
it.
is-
I do it
this
the
is-
opposite way, bro. I slam on the brake and I stick my arm out just to protect the passenger and
Right.
cop a free.
Okay, mom.
That's straight out of the 80s.
That's a free cop, dude.
Yep.
Got that off Seinfeld. From
So is
George.
that basically what Omnivore is talking about? Like,
Yes.
do we need to have this sort of like academic method? Like, otherwise I don't understand. You got to have this third derivative, second derivative of acceleration or some shit. I mean, come on,
That's
bro.
what it is. That's
You
not
just
academic.
basically
I believe
What
you
it
think
is.
the categorization and definition of like how human beings write it down is the answer rather than actually just the nature of the reality of it. And then you just basically spruik that as like your superiority complex.
Are you serious? Were you not paying attention? So Essie posted the video. He talked about jerk, and I was like, if I recall correctly, jerk is the third acceleration of motion. You know, the third derivative of motion, which turned out to be true. Okay.
Well, this is
That's just
different.
human beings
Hold on,
defining
this is-
things.
Jerking is different than jerk, how you explain it here. Jerking has a different definition.
Okay. Well,
What is it?
So, would you like to know what it is?
sure.
So they thought the expansion of the universe was constant, speeding up constantly, right? Now, jerking, they found out that it's not constant. So that's what jerking means in this context.
That's
Yes.
exactly the same as Omnivore just described.
Yes, that is exactly.
Is it?
What yes. Yes.
So can I rephrase like independently or attempt to?
Yep.
You said scientists used to think that the universe was expanding, increasing in velocity at a fixed rate. That's increasing at velocity at a fixed rate is a fixed acceleration. Jerking is if that acceleration also changes over time,
Okay, then.
which
yeah,
is what
then
he
it's the
described.
same. Okay.
So when
And where would
Ritsky was like, "Do you believe that without without evidence? Because you read it in a book." He's asking about the definition of the word.
where'd
Wait,
that
in this
force come
case,
from? Where'd
it's a
that
math
force come from?
problem.
Or are you going to say there's no force there, like you do with relativity?
No, I'm not.
So jerks
talking-
without force.
I wasn't talking about the universe. I was just talking about the definition of jerk or jerking. That's all.
You can jerk in a car. You can jerk in the universe. You can jerk on a rocket. You can jerk going down a flight of stairs or walking down the sidewalk.
Right.
You could measure the jerk in that system.
Correct.
What
yes.
about the universe, Omni? Is the
I
universe
have no idea.
itself?
I haven't looked at I don't know. Maybe. It could be. I have no idea.
It's a short video, by the way. It's 1 minute, so
Okay.
you can.
All right. I mean, I'm going to guess that if they made a video about it, there may be some there's probably some degree of credibility to the claim, but I haven't seen it. So the question of do you believe this without evidence for the universe, like I could accept it for the sake of discussion. I could accept there's evidence for it. I don't know how conclusive. But for the definition of jerk, it's a dumb question.
Yeah, I'm reading here. Thank you, Omni. Appreciate it. supposedly the last jerking event was, or the jerk event was 5 to 6 billion years ago, perhaps.
Okay, I don't know. I mean,
Pretty
that
interesting.
I have no opinion on that yet. I have not looked at it. The question was about, Rixie being upset about the definition of jerk.
By the
What
way,
year?
there's
7 million years ago?
So what is this? Hold on, real quick, Essie. What is this? Just dark energy is changing. It's not constant.
oh, they don't know. They don't know.
It
Well,
was
this
before the
jerking
globe,
thing
though.
is the jerking thing is with dark energy or the whole
Yep.
universe.
Yep, it's with dark energy.
You're
So
saying
it's
there's
saying
dark jerk?
the expansion rate changes. It gets slower, faster, slower, faster.
No, are we talking about the South Korean team discovery thing?
No, we're talking about the expansion of the universe.
I know about
Yeah.
are we talking about the South Korean team that came out with the big break to universal expansion, the gravitational the constant of the pushing? Is that it? We're saying it jerks. Because I'm pretty sure that was debunked by pretty recently.
So there was
Well, I
no
don't know
jerk
what you're
event.
talking about, but I was just about to bring up a new finding that they're saying they were wrong that the universe is expanding and it's actually slowing down. Is that what you're
That's by
talking?
that's by the Korean team. Yeah, that
Right.
is debunked. Yeah, that is debunked.
Well, I'm not so sure it's debunked. There's some people that don't agree with it, but how are you saying it's debunked?
Pretty much everybody else disagree with it. They're misinterpreting the strength of starlight based on distance in a way that everybody else accounts for. They didn't account for it in the calculation, and they say, "Oh, hold on, maybe the big crunch is back on the menu, where the universe collapses down and crunches in again." This is just
You mean the
not. They
supernova?
misinterpreted the data.
You mean the
What?
supernova data?
Exactly. Yeah, and the light coming off of there in relation to redshift. They screwed up that calculation badly. Yeah. Pretty much all of academia is against their conclusion, and I don't even know if they put out a correction on their statement, but it is the South Korean team we're talking about here, right?
I'm not sure. I read about it a few days ago, actually, and I wanted to bring it up.
Yeah, it probably is them. That is, I don't think that is no longer relevant.
So it's the
Cosmological
one that
constant stays on the menu.
it's the one that's based on the supernova luminosity, correct?
Yes. Yeah.
Okay.
So you're still expanding, I guess, in your belief.
Yeah.
They just don't understand light. That's all.
Oh, it's
Well,
just that, somebody comes up with something, they do another test, they disagree with it, some agree, some don't. It's part of, they don't all agree on a lot of stuff. I should do a series on it, like
well,
cosmological disagreement, number 1, number 2, number 3. Yeah.
this is one team and nobody else agrees with them. This is like a very, very big outlier. It's not like, oh, scientists are disagreeing. Where is this going to go? You know,
Kinetic,
I,
what are your thoughts on expansion or Omni? Oh, go ahead, Omni. Go ahead.
I don't think that cosmologists disagreeing about things is a problem. Like
No, yeah, exactly.
that doesn't worry me or make me think they don't know what they're talking about or anything.
Beautiful.
No,
Yeah,
I
just like
agree
we
with
have.
you.
That's why
that
we
is
have a
how
lot of
science
younger
progresses. Yeah.
creationist scientists coming out now. But I'd love your thoughts on expansion. So, what is space expanding into in your thoughts, if you don't mind me asking, to create
It's
new space?
not expanding into anything, according to the. So, I first off, this is a hard question to wrap your mind around. Okay, so there's going to be a point where you'll say this doesn't make any sense, and I'll agree with you, and then you may think that means it's not happening, and we won't agree on that.
Why don't you start
So
off with defining space so that way everybody's on the same page? Because I already know you're going to go with your raisin bread analogy, but that doesn't account for the increase in volume. being that's what space
I
is
don't.
definitionally.
So space is just what the environment that we exist in, whether it's got lots of stuff in it or a little stuff or quantum fields or whatever. I don't care about that.
Can we say it's a volume?
We could call it a volume, sure.
Okay, so let's say space is a volume. So you're
Okay.
saying that space isn't expanding, meaning the volume is not increasing,
No,
right?
the volume. Well, so space, according to the current cosmological model, and I'm not asking you to believe it, is infinite.
Because it's flat, but that does not conclude it's infinite, though. To be clear,
We don't
but
know.
yes, that is
We
the.
don't know for a fact. We don't know, but
I mean, is that logical? Let's just expound on that for a second and
I don't think
hypothetically
Yes,
you can
assume.
please.
I don't think you can logic your way around this.
Yeah, I don't think that's logical. I don't think that fits, right? Just to
It
say it's
absolutely
infinite.
is.
Okay, so go ahead and do your logic, but it's not, it's not that
Well,
interesting. It depends on what assumptions you start with.
Kinetic wants to get in. Go ahead, Kinetic.
I was just going to say, if you want to imagine something infinite being space as a concept, you could just imagine if you think it's like a sphere expanding, if you have that model and you're like a blowing up balloon, even if that was the case, which it probably is not, then if you were at the edge and you could dig past the wall, what would you even call that on the other side? That would still just be what you call space, right?
So I will promise you that what people are imagining is an expanding ball of galaxies around which there is, infinite blackness or a bubble, and outside of the bubble
Hmm.
is like God or something.
Hmm.
But the cosmological model is that it's flat or incredibly big, and it is isotropic and homogeneous, which means that throughout all of creation in every direction, there's the same amount of relative matter and energy everywhere. So there's just infinite galaxies and infinite nebulas and all infinite megaclusters every direction. And it's also getting bigger.
So
Which
Omni, with that, so it was together at one point, right? If it's getting bigger, was it small at one point, like the size of a period on a page?
no, I don't.
Hold on. How does something grow? How does something infinite grow in size?
Okay, so are you familiar with the concept of greater and lesser infinities? Is the first question.
Yeah, you could have something that gets infinitely smaller, infinitely larger,
No.
hypothetically.
Okay,
Whole
so
numbers versus even.
well, that's one. So that's actually, yeah, that's a good way to start it. So all of the whole numbers, 1, 2, 3, 4, 5, and then just the even numbers. The whole numbers contain the set of all even numbers, right? One larger set, theoretically, got more, there's more numbers, there's odd numbers in the first one, contains the set of all even numbers. But that's not all. There's more. So those infinities are actually in the lexicon of infinities the same size. They are both what they call countable infinities. Even though you can't count them, you can match one whole number to one even number, and you can do that for an infinite amount of time, and you'll always be able to match them one for one. And even though there are theoretically more whole numbers than even numbers, it's still a matching. However,
However, yes,
so
but Omni, the thing is, this is all metaphysical, right? Metaphysical
no,
isn't
this is
physical.
math. This is mathematics.
Yes, but it's not physical.
Math magic.
Yeah,
Well,
we can have infinities in math all day long and until the cows come home, but the fact is, it's not physical.
so well, okay, that's you can say that. But when we start talking about something that is expanding and infinite, then you can throw yourself at the ground and beat your hands on the ground and say it's not physical, it's just metaphysical. But that is what we're talking about.
I got you. So
So
I'd love to explore what you believe. So, just one quick moment. If Kinetic, you're still here. With this
Mhm.
idea of the bread expanding, let's say we have the dough in an oven, and let's say we don't even take it out of the oven. We keep our oven is let's say it's 2 by 2, 2 foot by 2 foot, right? And a cube, and we just let it expand. the space is already there for it to expand into. So even if the bread, if you are, or the people creation is in the bread dough, it still has space to expand into until it
Free
reaches its
space is the
area.
dough.
Yeah, you're imagining space time inside of some larger encapsulation structure.
Correct. Yeah, that's what.
Yes. So are you saying, yeah, because I'd like to know your opinion. I do you believe all matter was condensed to one area?
Well, from what we on the scales we perceive now, but it's you can have forever on a scaleless thing. But the reason when we look at vast distances, as far as we can look, we measure, we can see no curvature to the structure, right? Which is why they say that space time is flat for all we can tell. Either
No,
it
I get
has to
that. I
be.
get that, but this is kind of far away from where I'm going. If that's okay, I'm with you there. But can you just follow me on the logic really quick, if that's okay? So, you believe that matter was condensed to one area?
Not necessarily, because matter is condensed quite a while after the initial part of the Big Bang. It's not all just matter condensed; it is energy in
Yeah, that's a good
fluctuation
point.
state, and then it condenses as it moves out. So it's sort of like if you see steam moving out in a cold area, you see the water droplets form a little bit afterwards as it cools down, right?
No, I get that. So all the energy and whatnot is condensed, right? Because we have matter. There's no escaping the matter that we're standing on, we're surrounded by. It was all compressed, localized, in your opinion? I want to steel
Well,
man your position. I want to know your
Let me
position. Do
let
you
me
think all the
there is
matter
such
was
a
condensed
thing.
because of gravity?
There is such a thing. I mean, if Sir, yeah, essentially, but if Sir Roger Penrose is correct, for example, that is a conformal cyclical cosmos, then if you talk about the heat death when it expands so much that even atoms are ripped apart into photons and black holes are all evaporated, all you have essentially is light. But if you are light, then you travel distances instantaneously. You have no time at sea. So if everything is light and you have infinite distances, but those distances are traveled instantaneously, then that could be such a thing as the origin of a new eon of a Big Bang, for example. That is what
I was
he proposed.
going to say
Do you believe that?
I was
Which
going
one
to
do
say to
you believe?
Omni.
Well, can you hold on a second? I'm trying to deconstruct his belief. Is that all right? If you could write it down, Bull Knight, or if you want, go ahead.
Well, so I don't think that if depending on how you interpret cosmology, it may be that the universe was infinite and always hot and dense, and then the Big Bang happened everywhere, and it became the galaxy, the universe that we see today. But the idea that there was a vast empty area and everything was just compressed into a tiny ball and then it blew up is not the current cosmological model.
No, I got it. I got it. I'm trying to understand without further distraction or interruptions, if that's okay. Are the flat earthers okay if I help deconstruct Kinetic's thoughts here? We already know what the Globers believe, but I want to know what Kinetic thinks, and maybe we can deconstruct it.
Is he not?
Dyslo, is that okay? Maybe the Globers here? A
Is he
flat
not
earther?
a Glober?
Yeah, I see. Are you still here? Is that okay? I don't want to hijack the conversation. I can wait for another time when it's just me and Connect.
Well, I just wanted to ask one question to the expansion believers, right?
Okay.
And then a follow-up. Is the universe everything and all?
Definitionally, yes, I think.
Okay. It would
Or at
have
least
to be the universe.
all in the physical realm.
Right. So the follow-up question is, if the universe is all and everything, where does it expand into?
But that's like the bigger infinity question.
Yeah, the size of everything is expanding. And I was going to say, it makes a lot more sense, at least to me, when you look into what the mainstream consequences of this concept are, as in the heat death of the universe. What does that actually mean in terms of everything's now too far away from everything else, and free space itself is now so sparse that nothing can happen?
Well, that's another controversial, I can't even say it,
Versal.
controversial topic, right? Because the Grand Poobah of all cosmology doesn't believe that. He believes in a cyclical. There's a new theory out there, a cyclical.
Sure.
So it doesn't contract. It goes all the way out, dies out, and then rebangs again. If that's like complete another nonsense, but
Yeah,
that's the
if free
grand
space
poobah.
gets so rarefied that at the center of it or at a certain point it now has zero resistance, something could
Yeah,
happen.
but if
Those are being argued and debated and experimented against currently. There's nothing wrong with that. But as far as what is space expanding into, that's like asking, is there ether outside the universe for the ether boys?
No, there's not.
no,
Exactly.
no.
There's not. But I mean,
But you can still ask the question.
It's logical when you presume that either the entire universe compressed down into a tiny BB with nothing to support it, being that space and time and energy and everything combined, compressed along with it. So what would be there to support that? I mean, it's highly illogical, and likewise the fact that it's expanding into nothingness, which is absurd.
No,
So
it's not
But
expanding
that's
into
why I
nothingness.
want to
That's not
deconstruct this with kinetic, if that's
the
okay. I
case.
kind of let you
The
guys
universe
go on the side here,
expanding.
The
but
universe is isotropic.
so when you say isotropic, what are you referring to specifically? And then you want to add the caveat of being homogeneous.
Yeah.
Is I
So
mean,
what it means is everything around us that we see continues the same in all directions infinitely.
you're just saying the medium's consistent.
The
and
not just the
infinite.
medium, the stuff in the medium.
Right. I mean, that's part of the medium.
All the galaxies and clusters and everything extends infinitely.
Well, that I wouldn't say isotropic is inferring infinite. That's
No, okay.
that's where you
So
start getting illogical.
throughout the universe, if the universe is flat, as it appears to be, then it expands infinitely. If it is positively curved or saddle shaped, negatively curved, then there could be something else going on.
And then what are you saying in terms of homogeneous?
That the spread of density and matter is roughly the same at large scales everywhere.
So you're saying there's no gradient.
Right. It doesn't peter out to nothing or something like or build into a wall or anything like that.
Which seems
That you know of right now.
antithetical to what was it Bull Knight was pointing out, how things become sparse and rarefied to the point where there's no
hold on.
resistance.
No, it doesn't. Because right now it's like imagine a set of like a twister board, like a set of dots on an infinite sheet of paper, right? It's infinite in all directions, 2 dimension, and there's a dots 1 inch apart all over the paper. Now, somehow, the brain busting part, so the piece of paper starts expanding, so now those dots are all 2 inches apart. And then another few minutes, even though it's infinite, it's still stretching somehow.
Yeah, that's the problem. That's where logic starts falling off the second you invoke
That's okay. Well,
infinite.
I
mean,
don't think
And goes into
you can
pseudoscience.
declare it not to be logical.
well, it's not. I mean, is there anything in reality you can show to be infinite other than your conventions and concepts and hypothetical thought experiments?
I mean, I don't know. No, I don't think so. The infinite
So
things are pretty big, like the known universe.
why would you place that problem upon reality if you already
Exactly.
if you already see reality doesn't comport with the narrative?
So that's a
Biased?
great question. So first off, there's a limit to how far we can see, right? And that limit is governed by, for example, the cosmic microwave background. So it's about 46 billion light years in every direction. So we can't see, and we never will be able to see beyond that limit, apparently. However,
Even if we send something out like a probe further
No.
out to extend the
Nope.
vantage point.
no, not unless it can
Really?
go faster than light.
Oh, okay. So here we go. We got an issue with physics here. It's a physics barrier, not a lack of limitation in terms of perception, but it's your problem. It's a problem of physics.
Well, it's however you want to describe it, but if it can go faster than light, then yeah, it can get out through that.
And we've
Isn't
tested
it
this.
more logical to think that it's kind of nonsensical for them to think that they can see the whole universe, the edge of the whole universe, precisely because of what you just said, Omni. And all they're seeing is just, stars or whatever, red shifting and traveling faster and faster. What's more logical? To say
Nobody
that
thinks that
all the
the universe.
universe is
Nobody
expanding,
thinks.
or
Nobody
they're
thinks.
just witness. I'm almost done, bro.
Okay.
Or
Nobody
they're
thinks.
just witnessing something traveling fast.
I don't know.
I
But
don't
nobody
believe
thinks
either.
that's the edge. Nobody thinks that the furthest we can see is quote unquote the edge of anything.
Then
They
how
call
do
it
they
the
know the
observable.
universe is expanding? How do
They
they
call
know
it the
that?
observable universe
Right, the
as
observable
a
universe.
specific.
Yeah, but
So
it's
by
not.
definition, I'm right in what I'm saying.
No,
They're
because
just witnessing something moving fast.
okay. If you, I mean, I
No,
don't.
think about it. If by your own admission they're not seeing the edge of the universe, then how do they know it's expanding? Come on, man.
Because
It's like
everything
nonsensical.
within the because everything we can see within this radius is getting all of it is getting further away from everything else.
Okay. So how does that relate to the edge?
So it doesn't. The edge.
Exactly. Exactly. See
So
how easy that was?
Omni, do you mind if I help? Can I
Okay, I mean,
deconstruct
go
your?
ahead.
Hold on. Before you go,
Okay,
do
sorry.
you understand the logic
No,
in that, Omni?
no, I
You
don't.
don't understand the logic in that.
Nope.
What was it? Repeat it, Essie.
By their own admission, they cannot see the edge of the universe.
Right. They said they can't go beyond 46 billion light years, I think, is what Omni said. No matter how far out they probe. So if they were able to probe half that distance, let's say 22 billion light years, they wouldn't be able to extend their
Right.
perception.
So
And
let me explain what the effect of this actually is. So everything is moving away from us in the observable universe. Everything is getting. Remember those dots on the infinite sheet of paper that are it's expanding, and the dots are all getting further away from each other.
okay.
So these other galaxies around us and other superclusters and stuff are all moving away from us. Eventually, they will pass that 46 billion light year wide wall, and all we will see is our own galaxy and nothing else, just the
Okay.
Milky Way.
Okay.
Okay,
But
so let's say that's true. How does that relate to the edge of the universe expanding?
So
How
yeah,
can
where
you
because
is
make that claim?
well,
so
yeah, he's acting as if it's extending into this vanishing point that can't be
no, it's not.
perceived
No, it's
beyond.
not vanishing. It's not vanishing. It's just going beyond where we can see it.
I understand, but if we're probed out half the distance, we should be able to increase the 40 to the 46 marker to further out.
So if we could, so part of the problem is that the rate of expansion is extremely fast, and the amount that we can move is limited by the speed of light. So in the let's call it the world as science understands it, even if I took off from the Earth at the speed of light, I wouldn't be able to outrun the expansion.
Let's say there
Would you
was
expect,
let's just
Omni?
say there was a mirror at this vanishing point. Would we be able to reflect back and perceive it from the past?
Would we be able to reflect our own? Would we be
No,
able
no,
to?
the light that you're saying is moving at light speed to the vanishing point. Would we be able to reflect it back and still gain perception of what was once there?
No, there's a point where it'll never come back to you, bro.
Yeah.
Well,
Omni, would you I have a question for Omni when it's in a second.
yeah, go ahead.
Would hypothetically, with your understanding, if we could teleport a probe halfway between us and the CMB,
Right. Okay.
it would only be able to see under current models its own 43 billion
Yeah,
light
it would,
years
right.
sphere.
It would, yes, if we could teleport it, through space time to that way, then it would create another sphere of that radius out there that we could see.
You assume that, You
Well,
don't know that.
That's the model. That's what we're talking
Oh,
about.
right.
So
Yes.
Omni, would that make like a
The
globe
problem
around
is
you?
seeing further than that is that the universe is only X billion years old, and the cosmic microwave background was opaque.
Thank you, Omni. Would that make it equally distant in all directions? Like, so if we were at the North Pole and we're just looking directly up in that
So you
direction?
can't see through it.
No, I know, but would that? I guess that
He said it's
distance-
flat. He's giving contour to it. Eden, if you weren't following.
Well, no, I get that, but I'm saying like,
So
okay,
no,
so
the
it's-
universe being flat and our observable universe.
yeah, the observable universe, is it in every direction around the globe?
Yes.
So if
Yes.
yeah.
Yes. That's
so it's like a
sphere.
big globe around the globe, essentially.
So then
A big
why are you
sphere.
why are you presuming a flat universe? If you can if you're seeing equal distance, why would you presume a flat universe?
Because
Exactly. That's another problem.
a flat. So the reason why we would assume a flat universe is because, with the exception of like planetary gravity wells, as near as we can tell, space-time and Minkowski space, which would be like between universes, between galaxies, is flat, not positively or negatively curved.
So that doesn't comport with the cosmological model.
It
Because
does.
if there was a Big Bang
No,
and matter dispersed evenly all around like a grenade, there's no way that it would become
that's not
this.
actually the cosmological model.
Yes, it is. Yeah, even though as much as you want to deny it, that is exactly it. You said it yourself. It's homogeneic and isotropic. You said it yourself before. That is the model.
Yeah, you're
But when
actually
they,
that's
please
true.
don't interrupt.
You're giving
Hold on.
gradient now to something that you already openly
No,
admitted was homogeneous.
Well, okay, all right. So this, like I
You
said,
guys are interrupting, man. You're not letting me finish my sentence.
okay. Go ahead and finish, and then I'll try to answer it.
So you can't answer that. You can't have an explosion, the Big Bang, a grenade, putting everything around it like a ball dispersal pattern. And then when you look at it, when they did the CMB stuff, right? Then they found out that it's flat. So those two things do not comport with each other.
I think he's done on me. Go ahead.
Okay, so there's a couple of things that are very badly explained in pop science, and one of them is the Big Bang as a hand grenade.
Okay.
That's not what the theory actually says, to my understanding.
Well,
One
it's
second.
worse than that because when you question them, sorry to interrupt, because since you brought it up, this has been very important. I'll give you a third nonsensical thing about it. When you ask them that, where is the center? They say there is no center.
Correct.
It banged evenly
Yes.
all around.
Yes.
Correct, Omni?
Yes. Yes.
So that's three nonsensical points right there that don't match.
I understand. So, like I said, I can try to explain this to you. I don't know that I can.
You can't, but go ahead. Go ahead.
Okay, well,
Just dumb it down. Tell him like he was Canadian or
there's
something.
no way to dumb
Yeah,
it down.
pretend I'm Canadian.
It's a brain-breaking cosmology. So, however, it does. The kind of the learning from this is that relativity is not intuitive. So, first off, my understanding of current cosmology is not that it was all compressed into a little ball. I've seen that said before. I've seen it said in science write-ups. I don't think that that's the current understanding. And
What a rebel.
Which is whoa. What do you mean? Which part is not? The
We have a
bang as
rebel
a
here.
grenade?
All mass was compressed into a dot.
He's got a preferred shape. What's your preferred shape, Omni?
Cube?
What do you identify
Triangle?
with?
Flat universe.
Like a squished basketball. Like if a car were to run over a basketball like that.
No, not like a dot. No, just that the universe is flat. Meaning
Okay,
it doesn't have a
let's.
positive or negative curve.
Okay, but I mean, you're saying words right now. Just give it to us in some sort of relatable analogy or shape or something.
There's not. Okay, so the relatable analogy is going to be even harder because you're going to say, I'm going to give you an analogy, and then you're going to treat the analogy like it's the actuality. So the analogy is an infinite sheet of paper with little, with all covered in little dots, and they are all 1 micron apart. That's the universe.
That would be.
But
The
hold
universe,
on.
would that be ether? Would that be the density of ether over
Yeah,
distance?
because they say it was compressed, so that's in its compressed state.
So when they talk, yes, because it is incredibly dense. So remember that all of these dots are a micron apart, right? A teeny tiny amount apart. So the entire infinity of the piece of paper is all dense.
Well, hold on. In their model, were atoms touching under that compression of the Big Bang?
Non sequitur.
Yeah, non sequitur, unfortunately.
No, it's not a non sequitur because
It turns out it is.
you guys claim atoms don't touch, but in this condition, I feel like they'd have to.
In this case, there would be no atoms.
Really?
Yep.
Okay. All right.
Called the density of free space. That's why I brought up the density of ether to try and bridge the gap.
Matter's not existent. Like the makeup of the blueprint of the matter's there, but it's not actualized yet or something. Is that what you guys are trying to say?
It is hot and dense. So there's not a blueprint of
it's
matter.
Incompatible, right?
Yeah,
like
it's not like there's no model of physics that describes it.
So is it? Would you say it's in a potential state or a physical state?
I'm telling you what. Okay, well, look. Let me. You're asking me to try to explain the model as I understand it. You could say I'm wrong about the model. Fine.
No, I didn't ask you that. I asked you to explain the things that don't make sense. Number one, the Big Bang as a grenade. That's one claim. Matter expanded all around. I'm re-explaining this because Elbow and some new people.
Okay.
So that's model number one. There was a bang at a certain place. Matter dispersed evenly all around. Okay, that's one. The second one is that they say, no, that's not what happened. The bang happened evenly everywhere. And the third is that they say that the matter is dispersed flat like a pancake. So those three things do not comport with each other. That's
like
what you're supposed to explain.
Right.
You realize I had him on the ropes, SE, right? I mean, this is part of his explanation. He was in the middle of that, and he didn't have a shape to comport or share.
There's no shape.
It was just the stretching of microns away from one another.
Okay, so once again, you asked for an analogy. Okay.
Wait, hold on. Why do you say there's no shape when you say it's flat? I mean, that's contradictory.
Well, you asked for an analogy. So so flat deals with the curvature of space-time, not two-dimensional flat plane.
Flat like fizzy pop in a soda can, or flat like?
No, it means not. It means not curved. The flat is in like a 4 spatial dimension sense.
Are you following?
I don't expect you to follow that. That's
come on, man. Come on, bro. I think I see Danny wants to get in. Maybe we should let Danny.
This is almost worse than Ken Wheeler.
Yeah, this is well. Let's not go there, but this is ridiculous.
I think you're right. I think it's worse.
How much worse?
Maybe Danny, a cosmologist, could explain this to us.
A very common misconception of the Big Bang is that space existed, time existed, and then at some time in the past, matter suddenly appeared as a point, a lot of matter, very dense, very hot, and it began to expand into that space. That's the impression many people get. and it's suggested by the name Big Bang as well. But that is not what the Big Bang model actually is. Big Bang model is that nothing existed. When I say nothing, truly nothing, or even something less than nothing, in the sense that
Nothing.
not only did matter and energy not exist, but space and time did not exist. And then at some point, space, time, matter, energy all popped into existence.
So you're saying something comes from nothing. I mean,
That's exactly what it
I
is.
know, I hear it,
Okay.
and I've got Omni telling me it's infinite and it's flat, but it's not
Well,
flat.
one thing at a time.
It's
One thing at a time.
okay, all right.
But the first thing is you need to make sure that you understand what the Big Bang model is. Otherwise, it's a misrepresentation, amounts to a straw man argument. So you got to kind of clean out the cobwebs and get the model right if you want to critique it. So it's a sudden appearance of matter, energy, space, and time. It's very hot, dead state, and it's getting larger. That is, the space is stretching or expanding, which is causing the temperature and the density to drop. And this means that the Big Bang at the beginning of the universe filled the universe. The universe was completely filled. There was no part of the universe that was empty, waiting for matter to reach it. It was
You
filled.
said all that came from nothing.
Well, that's basically what the model says, yes.
But nothing has zero matter, so how did something with zero matter?
Well, that's an entirely different question. I'm just simply describing what the model is.
But that's not a very
The model
valid
itself,
model if something
the
is
model
coming
itself does not say where the universe came from. It just simply says the universe happened, and this is how it happened.
You told us it came from nothing.
So
You said absolutely nothing.
you might want to let him finish. Let him finish, Locksmith.
That's what the model says, that the universe suddenly appeared. And it's again the sudden appearance of matter, energy, space, and time. So again, I want to make sure you understand it's not matter expanding into space. It's an expansion of space itself. And
So you just have a supernatural religious belief?
Well, this is why Einstein
you keep
wrote the
harping on
book.
that, and that's not what I'm prepared to talk about. I'm simply describing what the model is, and so when you expands, and the flatness refers to the curvature of space.
Yes.
And the
Well,
observations,
those are antithetical. So when you say flatness refers to curvature, that's where you lose me.
Well, this is why Einstein wrote the book Cosmic Religion. You need to look into that.
Flatness means that there is no curvature, that the universe is geometrically flat. It's Euclidean in that sense. Now, there are other ways you can describe it. I like talking about the ratio of kinetic and gravitational potential energy. It's an alternate way of describing the universe, the value we call omega. But geometrically, it refers to the universe being flat. At one time, people, and I guess people still hold a candle for this, but the argument is that the universe is curved back on itself. And when it's curved back on itself, you can have a universe that's finite in size that has no edge to it. But if the universe is flat, then you do. If you have a finite universe, it must have an edge, and almost nobody wants that. So most people today assume that the universe is infinite. The beauty of that is the fact that nobody can say for certain if the universe is infinite or it's finite. No observation will tell you that because the universe is so large, you're seeing only a small part of it, and it's impossible to determine that.
I mean, wouldn't logic infer?
Exactly my point before. Exactly my point. Yeah, there's no way to know.
Wouldn't logic simply infer that, it can't be infinite, and it has.
I think we lost you.
I think you broke up. You broke up there, Dyson.
Do it with logic. It depends on what your initial assumptions are. If you start with an assumption that it can't be infinite because I've never seen anything infinite, then if I've never seen infinite, then the universe must be finite. I've never seen anything infinite, therefore the universe is finite. There's your deductive chain.
Nobody said that. Danny didn't say that.
That what Dyslow is saying is isn't it logical sense for it to be that it can't be infinite?
Yeah, well, he's trying to put logic into these reasons, but logic went out the door a long time ago because it is a religion. Even Einstein wrote a book, The Cosmic Religion.
All
Well,
right.
look,
I
the
mean,
religious part is when they say it came out of nowhere, nothing, right? But we're critiquing the model within the model. Of course, that part is nonsensical. Nobody, what do you mean nothing, right? But that's their model. So those are two different things.
Right.
Yeah, but if the whole thing is based on a non-logical, you know, structure, then why are you trying to find logic
yeah.
in
If
the
the
structure?
foundation doesn't hold, I mean, then what are we really building off of? I mean,
I
like
agree.
you've
I
got to,
agree.
yeah. So it's just it's a lot of assertions. It's a lot of things that one has to accept in order to build and move on. Unfortunately, not everybody's willing to, accept something illogical to build off of. But
Well, I mean, do you think that if you were asking a neurosurgeon about how brains work and the neurosurgeon was explaining it and you were like, that doesn't make sense to me, therefore the brain can't possibly work that way. Would
But
no, no.
the brain surgeon actually like does work and saves lives,
yeah,
as
yeah.
opposed to these, you know,
So I
cosmologists, these
well,
theoretical.
Theoretical. Yes,
Yeah,
thank you.
I mean
they don't do anything except
you can
postulate
say that, but
fucking
it's the
absurd
same
ideas. What have
level
they
of
done? What have they done for humanity?
well, it's the same level of arrogance.
Well, I was trying to critique the inconsistencies within the model and the various things that just don't make sense, even within their model. Example, the bang, which banged at one spot and dispersed matter all over, like a grenade all over. And then they say that
That's
no, it banged everywhere evenly, like Danny just said. And then they say it's flat. So
But
those are inconsistencies within their model.
they're pushed away from all that. Like nobody signed on to the Big Bang from that perception. Like they're saying that everything was already there essentially. It just wasn't manifested. It was like in this potential state, and then all of a sudden it just manifested and appeared. And
I don't
um,
think that's what Danny said. He said there
yeah,
was nothing.
yeah, that's the same thing. I mean, when something's actual versus potential, it's you got something versus nothing. But in the sense of no thing, it doesn't have like a physical quantification, but it's there. Kind of like energy, right? It's not created nor destroyed. It's just transferred. But the
I don't
problem
think
is
that's what I don't think that's what Danny was saying. I don't want to speak for him, but he's saying like nothing, no time, no matter, no space. Am I correct, Danny? And your
that's what
Yes,
he's
no
saying.
matter, no space, no time, no energy, and
Right,
then suddenly there was.
right. Yeah, I'm hearing him. That's what he's saying.
And again, the Big Bang model itself does not attempt to explain why the universe came into existence that way. It's merely trying to say that it did, and this is the aftermath is what we see in the universe today.
so
And
that's
it's
kind of
That's
like woo out there stuff, right? Like I mean,
not
what's
saying
nothing?
much, basically.
Well, that's their
well,
model. That's the. Of course, we
it's
don't agree with it, but let's
yeah,
scale
but I
down the
mean,
model correctly, is what I'm
well,
saying.
let's be fair. Not everybody in here agrees the Earth is a globe. So, you're not going to agree with cosmology.
Thanks,
Well,
thanks for the explanations, though, Omni and Danny. Those were really good.
Omni, did you care to explain the cosmic homogeny with your galaxy flatness?
Okay. Not galaxy flatness, it's space-time flatness, universal
Well,
flat.
you said it's a space between galaxies that's flattened.
No, no. I said one of the reasons we believe the universe has zero curvature is that as far as we can tell, the region between galaxies does not exhibit a positive or negative curvature, which is
Right,
why
you're
we
saying.
think that's my understanding. Danny may know better than me, but that's why we think that the universe is topologically flat.
That's correct. There are tests that you can do within the Big Bang model, observations that you can make. And this goes way back. I mean, not just Big Bang, but other models before that. This goes back before I was born, probably. And the interesting thing is the flatness is the universe appears to be flat to a high degree. It could be curved on a very slight scale, but we've not reached that scale yet.
So
And
what do
as
you
far
feel
as
about the inconsistencies, Danny, in the
what's the inconsistency?
well, what I explained, like banging in one spot, which
Well,
I know you don't agree with that, right? That's
no,
but that's
well,
one of
I'm sorry, I missed a moment there. What did you say?
the bang that happened in one spot, the infinite density one, as opposed
That
to the one
that's
you said,
that's not the
which it
model.
banged everywhere evenly.
Well, I didn't say evenly. Uh, the again, the universe did not start at one spot. It happened everywhere, but everywhere was a lot smaller back then. And as far as homogeneity is concerned, the universe is assumed to be homogeneous merely because the math works out a lot easier that way. If you have a clumpy universe, then you have to uh, model that clumpiness in. Now, fact be known that at small scales, the universe is clearly not uniform. It's not homogeneous. But I can give you an example of a macroscopic example, a small example. If you have a piece of material, say a piece of glass or a piece of metal, it could be polished, it could be machined and shaped, look very uniform, and we can model it. We can make assumptions about it and get very good results if we assume that the material making up that object is indeed uniform. It's like a fluid almost. However, we know that matter doesn't exist that way. On a very tiny scale, it's made of atoms and molecules. So matter that appears very smooth to us is actually quite clumpy. But at some point, that clumpiness kind of disappears, and it appears smooth and homogeneous. And the assumption is also made, the same sort of assumptions made about the universe is while it may be clumpy on the billion gigaparsec level, it's assumed that at some level it actually smooths out. The problem is we've not reached that level. The universe is demonstrably clumpy. So the assumption that the universe is homogeneous is an assumption that's approximately true, but not literally true. That happens a lot in physics too, in different
Okay.
situations.
Okay, so follow-up question then. Then then something has to be wrong here, right? It's either because they found with the CMB experiments, quote unquote, that the universe, the matter seems to be distributed, sorry, in a flat manner, correct? You're aware of that?
No, no, what do you mean by a flat manner? You keep coming back to flat as if it's a problem, and I don't see that it is. The flatness merely refers to the universe having no curvature. And the Big Bang model can accommodate either a positive curvature, negative curvature, or no curvature. So it's not inconsistent with the Big Bang model at all. It's just what version of the universe is the true one. The Big Bang model can give you an infinite number of different possible solutions, but observations will rule out many of those.
Right. Okay, I agree. So you're either saying that it could be all three, right? But when they did the measurements, they found out that it's the flat version, unless I got it wrong.
Yeah, the universe is demonstrably flat. There's no problem with that. At least I'll say it's flat to a high degree of certainty. It could be curved on a very large scale, but there's no evidence of that.
Oh, so you're saying it's flat as far as we can see, but it could be curving down the road, for example. That's what you're
What I'm
saying.
saying is, yeah, the universe could be curved on a very large scale we've not reached yet, but I suspect it probably isn't. Nobody knows for sure because we've not seen enough of the universe.
Okay, all right. That's I'll let somebody else get in. So not non-certain. Okay, I'll accept that.
Getting back to homogeneity, many times in physics, we make assumptions that are approximately true, but not totally true, and yet our results are pretty good. Sometimes good enough is good enough, and I think that's the same thing with homogeneity. On the really big scale, it seems to smooth out enough that a model of the universe can be done, assuming homogeneity, but there is clumpiness there. In fact, clumpiness has to be in. This is what the CMB little temperature fluctuations they're looking for the first time back in the 80s is all about. Because if the universe is perfectly homogeneous, perfectly smooth, the Big Bang universe I'm talking about, then as the universe expands, it will maintain that homogeneity, and you never end up with structure. You don't get galaxies, stars, planets, or people. So we're not here. So the initial universe had to have little tiny fluctuations in density, and the more dense sections showed act as gravitational seeds that
Let's
attract other
see.
material around it to give the structure we see. And if you have too much clumpiness, then everything gets sucked up into supermassive black holes. And again, you don't have galaxies, stars, planets, and people, and we're not here to see that. Consequently, there's some balance point in there where the universe just happened to fall.
Well, the
Can you go
CMB,
back
and
to the
this is
cause?
my last statement, and I'll let somebody get in. Since you brought it up, the CMB showed that it's definitely not the same everywhere. There's fluctuations. When they did the dual pole, the quadrupole, they found heat distribution is uneven. Even though it's very slight, it is still uneven.
Well, it's the
Yeah,
temperature of the CMB is within 1 part in 100,000 in every direction you look. You get these little fluctuations of a little slightly warmer, slightly cooler. When we're talking about 2.73 Kelvin, and the little fluctuations vary from that by 1 part in 100,000, that's pretty smooth. Now you're talking about the dipole and the octopole. That's a little different thing going on, but I think what you may be talking about is the axis of evil and the great cold spot.
That's right. Yep.
Yeah. And both of those defy explanation at this point. The great cold spot is too large of a structure to exist. It's too large by probably an order of magnitude, I'm going to guess. And it's no model right now of the Big Bang, no version of it can account for it. As far as the axis of evil is concerned, nobody knows why one hemisphere of the CMB is warmer than the other. Again, a slight variation, but not much. And the dividing line between those two hemispheres coincides with the plane of the solar system, which is an amazing coincidence.
Exactly.
Which
Exactly.
I published an article on this a number of years ago where I suggested that maybe CMB is an LMB.
Is a what?
LMB, not a CMB.
Explain.
A local microwave background rather than a cosmic microwave background.
Gotcha. Okay. Yeah. Well, at least you're honest. At least you're spelling out the discrepancies. So respect for that.
Well, it's easy for me to do that.
Yeah, Danny, can we get back to the cause of this Big Bang event? Like you said, there was absolutely nothing before
Hang
it.
on a minute. Hang on a minute. Can you explain the local, Danny, again? I mean, why local?
Well, if you've got this slight inhomogeneity that's global on the CMB that coincides with something in the solar system, then it suggests that somehow the CMB is linked to the solar system, something in the solar system. If that's the case, the solar system is extremely local. It's not cosmic. The whole word cosmic microwave background suggests it has a cosmic origin, but if it really is somehow related to the solar system, then it has to be local. Now, almost no I don't think a single cosmologist would accept what I just said because um, that's inconceivable to them. They would simply argue that the the homogeneity there, the axis of evil, which they don't know what caused it, merely by coincidence coincides with something local. And that I often ask people, how many coincidences are you allowed to have before you begin to realize they aren't coincidences at all?
Yeah, that part doesn't jive, like for sure. I mean, there's no explanation for that.
Yep, that's true.
Somebody else wanted to get in there. Who was it?
Yeah, I was
Locksmith?
gonna ask Danny. Yeah, because you described this Big Bang event, but you said before the Big Bang, there was absolutely nothing. So how could absolutely nothing cause a Big Bang?
That's a very good
Interesting.
question. And there's not a satisfactory answer for that. People have attempted. One of the most common, not the only one, most common ones is that the universe began as a quantum fluctuation. That would require that the universe, the energy of the universe be equal to zero. And I don't see any evidence of that. And furthermore, I think that argument is based upon a misunderstanding of the Heisenberg uncertainty principle and misapplication of that. I think
Mm,
it's a dead letter. I really do. I don't
but
think.
how's it a Wait, who's misunderstanding? Because you said that it came from absolutely nothing, right? So I'm just going off what you've espoused today.
Hold on a second.
All right.
Still here?
Yep.
Okay. Okay. What was the question again?
You said it was a misunderstanding of a Heisenberg principle, but so that implies like it wasn't absolutely nothing before the Big Bang. There was.
I think, as near as
Well,
I could tell, when people argue that it's a quantum fluctuation, a rule governed by the Heisenberg uncertainty principle, they're not arguing that it's really clever what they're doing. What they're arguing is that the universe popped into existence in a manner that's consistent with itself. The universe has no the some of the energy in the universe is zero. So there was no energy. There was zero energy before the Big Bang, and there's zero energy after the Big Bang. So no harm, no foul. It's a very clever argument that they're making. I totally disagree with it. So don't ask me to defend it. I'm just simply telling you what people are arguing about. And they get very
mm,
clever about it. One of the best treatments was written in a popular level book um, 15 years ago, A Universe from Nothing. And the name of the author is escaping me at this point. Common name, people remember him. He was at Arizona State for a number of years. He's an atheist, very antagonistic. He was the one who famously said that forget Jesus, the stars died so that you could be here. Somebody help me out. Uh, ah. Anyway, he's one of the proponents of that in a book he wrote, A Universe from Nothing.
hmm.
There are other ways to try to do that, but this is not really getting into the science anymore. It's getting into theology or philosophy. Personally, I don't think the existence of the universe has a physical explanation.
Now that's a big statement right there, right? Because really, if we get down to the nitty gritty, nobody really knows.
So
We have religious explanations, we have physical explanations, we have all kinds of, but if we get down to it, nobody really knows.
I agree that nobody knows. I don't think that the religious explanations conflict with the physical explanations. Um, I mean, obviously, people could contest that, but the fact that there is literally no idea what happened before the Big Bang, that no science touches that, means I don't think that you can make it. You can't say that any of that defeats a religious argument. I don't think that's in the structure at all. Now, my understanding from my reading, and I am 100% not a cosmologist and I am not a physicist, would be that the universe before did not have zero dimensions in all directions. It might have, but that it was, if it did have dimensions, it was simply hot and dense in all directions infinitely. And then the expansion started everywhere, with the, like I said, a sheet with, infinite number of little dots 1 micron apart. And then at the Big Bang, that infinite sheet starts stretching even even bigger, and the dots all get further apart, less dense, less dense, less dense. But that was, that was my takeaway from it. So, but the zero space, time, and all direction, certainly, certainly makes a different kind of sense to me.
Well, it's quite trivial, actually, if you have a quantum system, to show that it'll evolve in the past time infinitely. So that kind of hints towards there not being a beginning, right? Because if a system can be evolved infinitely into the past, then obviously there's no beginning to that system. And this is like a
That's the
trivial
definition
thing
of
to do.
trivial, of which I was not formally aware.
It's quite elementary, like it's simple